one side of my decagon. To find the perimeter, I have 10 sides, so multiply the length of your side by 10. And if we go ahead and multiply all of that out, our perimeter is going to be 58.71. I'll just round it to 2 decimal places again. Go ahead and plug that in to our formula. 1/2 the perimeter is 58.71. Next we just need to know the apothem. So head on back to our right triangle. The apothem is our adjacent side, and we know the hypotenuse once again. So the ratio I want to use that relates the adjacent side with the hypotenuse is the cosine. Cosine of my angle 18 is the adjacent side over the hypotenuse. My adjacent side is A. My hypotenuse is 9.5. Once again, A is in the numerator, so to solve I just need to multiply each side by 9.5. These would cancel out, and here's A. My apothem is 9.5 times the cosine of 18. 9.5 times the cosine of 18. That's my apothem. Multiply those out, multiply it by the perimeter, multiply it by 1/2, rounding again to the nearest square inch, so whole number, no decimal points. You should get 265, and we were measuring in inches, so inches squared. Inches squared. Okay, let that sink in a little. This will take some practice to get down, so highly encourage you to do the homework. I will do a couple example problems as well in a video for you guys. But now we're going to transition our mind. I told you this section would be sort of 2 parts. Here we revisited regular polygons, but had to use some trig to find missing measurements. The second part of this section on trigonometry and areas is revisiting triangles. Heading back to triangles. So if you flip back to the top of the next page, there are a lot of different ways to find the area of a triangle. We have one formula, base 1/2 base times height. Perfectly good way to find the area of a triangle. However, there are a lot of ways. I don't know how many. I know of at least 4 using different measurements. So it depends which measurements you know. Well, we're going to give you a formula to find the area of a triangle that only uses 2 of your sides and an angle in your picture. This is a theorem, so of course there's a proof behind it. There's a proof behind every theorem, but we don't have the time in class to prove every single theorem we cover, so here's another one where you'll take my word for it. But the area of any triangle, given, say, this picture, we'll call the sides A, B, and C, and we'll call the angles angle A, angle B, and angle C, using capital letters. The area of this triangle is 1/2 side B times side C times the sine of angle A. So we have area of a triangle given side, angle, side, because what we're using are sides B and C. Here's sides B and C. If you take the product of those 2 sides and then also multiply by the sine of the included angle, the angle formed by those 2 sides, whichever one that may be, half of that is the area of your triangle. Let's use it on a couple examples. What is the area of the triangle? So plugging into our new formula, the area of this triangle is 1/2, always have that 1/2, times the product of 2 sides and the sine of the included angle. So 12 times 21 times the sine of 48. And the product of all those pieces, you just plug it into your calculator, is 94 centimeters squared. Another quick example, the area of this triangle is half the product of these two sides, 10 and 16, times the sine of the included angle, the angle made by those two sides, which is 34. And if you multiply all those pieces together, 45, and we're measuring in inches, so inches squared. So a really long first part of this lesson and a really short second part.